Welcome back for chapter 3. This chapter is all about descriptive statistics and taking our raw data, instead of looking at it visually on a graph or chart, we're going to start looking at our data in numerical ways. And the first thing we're going to look at is measures of central tendency. Students are going to learn what a statistic is, what a parameter is, how to find the mean, median, and mode and their symbols, how to find the mean for grouped data, and also how to find the shape of the distribution. So in chapter 1, we introduced the idea of a statistic is a characteristic or measure obtained by using the data values from a sample. And remember, we said that statistic goes with sample because they both begin with S. And a parameter is a characteristic or measure obtained by using the data values from a specific population. And they go together because they both begin with P. The three measures of central tendency that we're going to learn about and use in this class are the mean, which is also known as the average. It's not resistant to outliers. We're going to see that here in a bit. The median, which is also going to be our Q2, our quartile 2. We're going to learn about quartiles in lesson 3.4 and 3.5. Is where 50% of the data falls below and 50% of the data lies above. It is resistant to outliers. And then the third measure of central tendency is the mode. It's the most frequent value of the data set. Now, the Greek letter mu represents the population mean. So population symbols they are described with Greek symbols, and usually just letters from the alphabet are used to describe our sample. So our sample mean is shown with this X and a bar above it, and we pronounce it X bar. So up above, I gave description how to find the mean and median in Desmos. I'm going to show you actually in Desmos here in a minute, and then also finding the mean and median in Google Sheets if you want to, but I would suggest doing most of your calculations, if not all. So the first set of data we have is the following data show the number of months patients typically wait on a transplant list before getting surgery. The data are ordered from smallest to largest. Calculate the mean, median, and mode. And so what I'm going to suggest is that we go to Desmos. So let me share my screen. And you can get to this Desmos link in Canvas. Underneath the video tab, there's a tab for my Desmos. So you can see how I did all the calculations. But I'm encouraging you to learn how to use Desmos and put in the data yourself. So I went to Desmos. I created a folder. That's why it looks like this. When the folders are pointed to the right, they're closed. And when you click on them and they point down, they're open. And you can see that everything that has a line, see this faint line, means that it's within that folder. And so to create this table here, if you click on the plus button up here and create table, it will create a blank X and Y table. And it's important that you know which XY you're using. So this one is X1, Y1. I only have one set of data, so I'm just putting it here in X1, and I typed it all out. Then I'm going to type in the command mean, and then in parentheses, I'm putting the column up where my data is, and my data again is in X1, and then median, and my data is in X1. So my mean is 13.948. I'm going to round to 2 decimals, so I'm going to use X bar equals 13.95, and my median is 13. Okay, I'm going to take you back to so again, our symbol, this is a sample of data. And the mean is 13.95 and the median is 13. So the mean is not necessarily a data point, and neither is the median. The mean is if we were to share all of this months with the earlier months that were lower, they would even out to be just under 14 months each that they waited. Now the median by definition means that 13 is the middle. And let's see how many data points we have. 1, 2. We have n equals 39. So there's 39 data points. So because I have an odd number of data points, the median will be the very middle point. So it'll be the odd middle point. So if 13 is my median, that means that there are 39 minus 1. So subtracting the midpoint. So 38 divided by 2. That means there are 19 data points that are smaller than 13 and 19 data points that are bigger than 13. And then the mode is the only one that you cannot find in Desmos. We have to count it by hand, and so it can be a little cumbersome if you have to count through several data points. But we can see that 7 is used 4 times. 1, 2, 5, or 10 is used 5 times. 1, 2, 3. 19 is used 3 times. 24 is used 4 times. So it looks like 10 is the mode. 10 is the mode because it was used the most number of times in the data set. 1, 2, 3, 4, 5 times it occurred. Let's look at example 2. Example 2 says, in a sample of 60 households, one house is worth $2,500,000. Half of the rest are worth $280,000, and all the others are worth $315,000. Okay. So this one is a little trickier because they're just describing what we have. So we have 60 households. Let's say 60 households. One house is the big kahuna. It's the $2,500,000. Half of the rest. So that means there's 59 here because there's 60 households total. One of them is the expensive one. So there's 59. It says half of the rest. Well, 59 is an odd number, so we can't just divide it in 2. So it's about 29. So about 29, half of the 59 is worth about 280,000, and all the others are worth 315,000. And then we have the really expensive one. So it says, which is the better measure of the center, the mean or the median? And how did you make your choice? Well, that's a good question. Because if we had just those two, let's say we just had 2 households that each one was worth 280,000, one house was worth 315, and we added them and divided by 2 and got the mean just between 2 data points. The mean would be pretty close to these 2. But if we throw in a house that is worth 280, or throw in a house that's worth 2,500,000, it's going to pull our mean up. So let's just go and look at Desmos for a minute down here. So if we had one house that was worth 280,000 plus the house that was worth 115,000, our average would be 297,500. But if we added in the 2.5 million, $2,500,000 house, we just increased our mean from 297,500 to 1,547,500. 500. So that's very expensive. So we can see that a really large number affects the mean, whereas a large number does not affect the median. So on this one, I would say that the median is probably going to be a better choice because it is not affected by extremely small or large values. Okay, let's look at another example. The next one says the number of books checked out from the library from 25 students are as follows. We want to find the mean, the median, the mode. So let's look at the mode first, because that one we have to look at by hand. So I'm going to look for multiples. I've got 2 zeros, 2 threes, 2 4s, 2 5s, 4 7s, 3 8s. It looks like the 4 7s win. So it looks like my mode is 7. And because there's 25 students, my little n is my sample size of 25, and it's odd. That means there's a middle value. So if we subtract that one middle value, we have 24 divided by 2. So we have 12 on the left plus the middle value plus 12 on the right. That makes the 25 data points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 13th one must be the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I didn't count 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's still 7 is our median, but I had to count this one over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I forgot to count this first 0 over here. So our median is also 7. So let's go to Desmos to see that one. So I'm going to click on my folder that says books from library. There's all my data points. And notice that my data is now in X2 is my column that I'm going to reference. So the mean of X2 is 6.16. The median matches what we came up with, 7. And we don't need the box plot. So that matches what we have. So they're fairly close. Okay. Okay, so I still have example 4. It says 5 credit scores are 680, 680, 700, 720, 720. What is the mode? Well, it looks like 680 is used twice, but 720 is also used twice. And so we have 2 values that have the same number of occurrences. So that means we are bimodal. Now you could have 3 values that have the same number of occurrences. That would be trimodal. You can have more than one mode. Let's look at example 5. It says consider the annual earnings of workers at a factory. The mode is 25,000 and occurs 150 times out of 301. The median is 50,000 and the mean is 47,500. What would be the best measure of center? So remember, we don't really have a hard and fast way to decide this. We're we're giving our best guess on what is the best choice, the mean, median, and the mode. So the mode happens $25,000 happens 150 times out of 301. So let's again think of this as like our box of earnings here. So 150,000 happens to, I'm sorry, 25,000 happens 150 out of 301 times. 25,000 happens almost half of the time. The median is 50,000 and the mean is 47,500. The median is 50. So it means that half, the median must be right here. 50,000 is the median. So half falls below and half falls above. And the mean is 47,500. So the mean, the average, is actually less than the median, which is something to acknowledge. The mean is slightly bigger than the mean. Oh, the mean, sorry, is slightly less than the median. So that's something to consider. What is the best measure of the center? It's pretty symmetric. If we know that we have about 50% up in this direction, it's fairly symmetric. Okay. Next is sometimes we have data in group frequency tables, like we looked at in chapter 2, and we need to find the mean, the weighted mean of those. So when you have a large data set that has multiple values with repeats, grouping the data and calculating a weighted mean can be time saving. You're going to put the data into a table with the first column being the possible data values. The second column will be the frequencies of each of those data values. The third column will be the product of columns 1 and 2. Then add the product column number 3 and divide by the total number of data values. The result is your weighted mean, or the mean if you would have used the original large data set. And I'm going to show you an example. So back to the number of months that patients waited on the typical transplant list before getting surgery. So there are many data values that occurred more than once. So I thought this would be a good data set to try. So I listed out the possible values of data, 3 through 24. And then here I listed how many occurrences they had. So remember that 7 occurred 4 times. And that was our mode. Actually, 10 was our mode because it occurred 5 times. And then we also had 24 occurred 4 times as well as 7. So we're going to multiply the data value by the number of times it occurred. So that means we had 7 times 4 is 28 and so on. Like 11 times 1 is 11, but 10 times 5 is 50. And then we're going to add up this third column here, which is 544. And we're going to divide by our count, which is 39. And so our mean comes out to be 13.95. And that's exactly what it was when we used Desmos with the raw data. Okay, so I'm going to show you the transplant list revisited. Here is the possible data values, and here are the frequencies in Y6. I'm going to take the total, so I'm going to add up the products of X6 and Y6, which is the 544 that I showed you. Here is the transplant revisited, X6 and Y6. And so there is that product of the data column and the frequency column is 544. And then the total of Y6 gives us 39. There are 39 observations. And you can also use the word count. And it gives us, actually the 19 is what we need, is the count. So then in this case, we have to have the total of the frequencies because that gives us the total of occurrences, right? Because our frequencies there were 5 occurrences of 10, 4 occurrences of 7. So we had to total up that Y6 to get 39. So that's 39 observations total. So 544 divided by 39 is 13.948, just what we had before. Okay. Next up, another way to calculate a weighted mean is also for data that's grouped into classes like we had in our chapter 2 with those grouped frequency distributions. So when you have a large data set that has multiple values with repeats, grouping the data and calculating a weighted mean can be time saving. So this is just describing how we're going to get our our midpoints. And we already did this in chapter 2. So I'm just kind of going back through it again. Now, we're going to go and look at the hours teenagers spend on video games. Mears conducted a study on the effect that playing video games has on memory recall. As part of her study, she compiled the following data. What is the best estimate for the mean number of hours spent playing video games? So we are going to add our midpoint, our lower and upper bounds, and divide by 2. And we get 1.75. And then we're going to do the same with the next. And we're going to get 5.5. And we can see that if we look at the width is the distance between your lower boundaries. So there's 3.5. And then here there's 4. And then here there's 4. And here there's 4. Now, usually they're the same, but not always. So between the upper boundaries, it should be the same as what's between the lower boundaries. So 3.5, 3.5. And then these should each be 4. So so then let's just validate. We're going to find our midpoint by 3.5 plus 7.5 divided by 2. So that's 11 divided by 2 is equal to 5.5. So the distance between the first one and the second one is not 3.5 because it's been rounded. So this difference is actually 3.75 here. But then the next two should be 7.5 plus 11.5 equals 19. And you're going to take that average by dividing by 2. And we get 9.5. And you can see that 4.5 to 9.5 is 4 again. And so this one's going to have a distance of 4. So 9.5 plus 4 is 13.5 and 17.5. Now, you won't always have to calculate these by hand, but it's important to know how they are calculated. So then we're going to go ahead and multiply. We're going to put these midpoints in a column and the number of teenagers in a column, and then we're going to multiply them. So let's head over to Desmos so that you can see. That's in this video games drop down. So here you can see I put my midpoints in X3 and my number of teenagers in Y3, and I multiplied them. And so down below, I said, find the total. So that means to add up this products right here and divide by the total in Y3, which is your count. And when you do so, you get a sample mean of 10.78 hours. These take more practice to get a good understanding of how to do them and what they mean and tell us. Now, in this case, these are this is an estimated mean because we don't know the actual value of the hours spent on video games. We only know what categories they fell in. So that's the difference there. Okay, the next example, example 7, is finding the mean of the following grades. So we have grades that have already been put into classes, and we know their frequencies. So there were 2 students that scored between 49.5 and 59.5. There were 12 students that scored between 79.5 and 89.5. So the first thing we have to do is find their midpoints. By adding the lower and upper and dividing by 2, we get 54.5. We get 54.5. Then we're going to do the same, and we should get 64.5, 74.5, 84.5, and 94.5. And now we're going to multiply these 2 columns together. I'm going to go ahead and just take you over to Desmo so that you can see how we can use Desmos for that. So in my Desmos file here, under the grades folder, I have my midpoint column in X4 and my frequency column in Y4. And then down below, I'm telling it to total that multiplication. So total the product of the 2 columns, and then total divide by the total of the Y4, the frequencies. And the mean, the sample mean, is 79.5 is a sample mean grade in that course. So the sample mean grade is 79.5. So you're probably wondering, like, how can we tell, have a more definitive answer on which is a better choice for measures of central tendency? So in a perfectly symmetrical distribution, the mean and the median are the same or approximately the same, okay? In a distribution where the mean is greater than the median, we say that the distribution is skewed to the right. I always write the mean on the left and the median on the right because the mean is alphabetically before the median. So this trick will always work as long as you put the mean on the left and the median on the right. If the mean is greater than the median, we would say it's skewed right. And if it's within a few data values, I would say it's approximately symmetric. Now, if it's clearly the mean is less than the median, we're then going to say that the distribution is skewed left. So if we say that we have skewed data or whatnot, then how do we decide what is the best measure of center? If we have skewed data, our best measure, that means they're similar in value, mean and median, and the mean is going to be chosen as the symmetric data value, is the best measure of center. If the data is skewed left, that's because the mean is less than the median, and the median is then going to be the best measure of center. If the data is skewed right, where the mean is greater than the median, then the median is going to be the best measure of center again. Okay. So in the last data set here, it says find the mean, median, and mode of the data set. And using Desmos, we will see that the mean is 20.56, the median is 22, and the mode is 22. And I'm going to compare the mean on the left to the median on the right. The mean is 20.56 and the median is 22. Now, you could say that they're a little bit skewed left, slightly left skewed. But it's a small data set, and we have several on that 22. So I would say you could really kind of say they're approximately equal, which means that they're approximately symmetric. This one is too close to really call a difference between them. Now, here are three different picture distribution representatives, and let's decide if the data is skewed or symmetric. So here we have the 2010 Winter Olympics gold medal wins by top 20 medal winning countries. And it looks like the majority of the data is over here on the left, and we have a few here around 9 and 10, and then this one country that had 14 countries that won top 14 medals and gold medals won. So I would say that this data set is skewed right. And that's because we have just a few data values out here to the right. The next one is a stem and leaf plot, which we learned about in chapter 2, the ages of former US presidents when they died. And so in this case, I like to turn them this way because then I can kind of draw a picture. They look pretty symmetric, where the center is in the middle, the high point, and then there's trailing off to the left and trailing off to the right. So I would say symmetric on this one. And then the last picture is the hours spent playing video games on weekends. And on the weekends, more people tend to play video games, so that's why they're in these higher classes of hours. And so this one, I would say, is a J-shaped or skewed left. So we learned a lot in this lesson. Make sure you take some time to go back and get your questions answered. Reach out if you need help at all, and I'll catch you for the next video.